All right, so here we go. I've been playing around with this 4-pin DC 12-volt CDI system. Very compact, but cheap. They don't cost much, about 10 or 12 bucks. And they're designed to work on DC, battery, like a 12-volt, probably even 6-volt, but it's designed for 12-volt. It's perfect for me. Anyway, there's an individual by the name of a fellow Aussie called Blue Jets on the forums, and he'd worked out a way using a circuit that's actually behind here that you could run this DC module, CDI, on a 12-volt system without an induction coil. These systems are designed to run an induction pickup coil for the trigger, and so he'd worked out a way of using a Hall effect sensor, which I've effectively got here. But unfortunately, myself and others have not been able to emulate what he's done. So, and I'm pretty certain that we've got the circuit right. Although this circuit I've changed now, I'll talk about that in a minute. Anyway, so Blue Jets he's got a few things going in his life at the moment, and so he hasn't been able to be, he's been a bit busy, so that's fine. But in the meantime, we plot on. And I've had a few suggestions about changing the circuit, and none of them have worked. They still won't induce a spark out of this thing. So what I did was, I've got plenty of pickup coils, but this is actually a coil out of a 24-volt relay. And I ripped it out of the relay, obviously. And you got these two terminals here. These are the windings. Now, when I put these windings on the trigger of this CDI, as a classic induction system, of course, which it's designed for, it works perfectly. So you can just run a piece of metal or a magnet across that, induce a back EMF in here, and boom, she works beautifully. So I sat on that for a little while and didn't think anything more of it. And then I thought, what about if I switch power to this thing? So I kept that going to earth. That was still going to ground, one side to ground, and the other side to the trigger wire. And on top of that, on this side, on the trigger wire, I put positive. And every time I tapped the positive terminal, it would induce a back EMF here, and I'd let go. And then that would send the pulse to the SER and the CDI, and boom, she'd throw a spark. I thought, well, that's okay. So then I thought, well, what about I use a Hall system and just make a very simple amplifier using a Hall system. That LED is just an indicator for seeing when it's on or off. It's not necessary. Just got a couple of resistors there and a simple transistor. I've ripped out all the other capacitor and everything. It's all gone. And I wired that up. So I had the trigger and the pulse switching wire from the little circuit here. And lo and behold, it worked a treat. It was no problem. I was running this distributor here is off one of my 9-cylinder engines. It's got a Hall sensor that we pot here ourselves. And it's got 9 holes here with a magnet behind on this keeper plate. And if I can get that to focus would be nice. There you go. And so that throws 9 sparks per revolution, and I had this lathe spinning at 2,000 RPM, which on a 4-stroke engine, would be 4,000 RPM on the output. And obviously this thing spinning at 2,000 RPM is going to be 9 holes, so 9 sparks per revolution. That's 18,000 sparks. And surprisingly, this thing kept up no problem. I was throwing beautiful sparks here. There's a spare one I've got. There's the one I've got wired in. And I look at the size I got the gaps at about 5-6 mil. No problem. I'll demonstrate that. And then I thought, well, this is good. It's a bit bulky. No, so I wasn't actually using this in the circuit. As an induction coil. I was using it. Well, I guess it is an induction coil, but I wasn't running anything past it. I was just using it as a pump and dump sort of coil to create an EMF. And I thought, well, that's pretty big. I wonder if I could get that smaller. Well, what I did was I went to the local electronics store and I bought a 12-volt reed relay. It's got a winding there. Look how small it is compared to my fingernail. It's tiny. And sure enough, I hooked that in to the coil. Of course, I'm not using the reed. I'm just using the coil. And in series with this circuit, or being pumped by this circuit, it's doing the same role that the big one was doing, this one here. So I basically replaced that, which is a bit big, and gone with this. And it works. So I cut off those terminals there. They're the reed contacts. Don't need those. So we're just using the coil. Now, I'm not an electronics expert, but this is working. So I'll demonstrate that now. Now, the other thing I want to show too is that these modules does have a very crude advance. In fact, it's got like, I'm going to imagine it's for kickstarting. So when you kickstart it, it's about 20 degrees retarded, somewhere around that. It could be more or less. It's actually where those two lines are. Now remember, this on a 4-stroke engine would be double that, because the crankshaft turns at twice the speed of that. So whatever those degrees are there, it would be double. So I figured on our engine it'd be about a 20-degree retard, something like that, which, considering our engine doesn't have any retard, that's perfect. That'll really help starting or stop any kickback. So the way it works is when the LED comes on, it sort of, builds the system up, I guess, and then when the LED goes off and it collapses, this little baby here into here, you get your spark. And the advance kicks in at about 2 or 3 or maybe 500-600 RPM, and prior to that, it's fully retarded. Anyway, I'll show. I've got a strobe here. We've got a strobe here, and we'll hook that up, and I'll show you how far it retards. And I'll crank this baby up. I'll start it off pretty slow, just normal, so we can see what's going on. About 780. 780, the strobe hangs in there. Any more than 780 RPM, remember I've got 9 sparks per, that's 9 times 780 RPM on the lathe. So the old Hella strobe can't really keep up. It's not designed to run that fast. So anyway, we'll get this fired up, and I'll show you it going. So, got my battery terminal here. I'll hook that in. It's already sparking away. And there's my spark plug. There's my setup. So let's safely turn the lathe on backwards. And there she goes. See it sparking there beautifully. That's a nice big gap. You can see my LED here. So when the LED comes on, there's no spark, but that does fortuitously work out to be where it will spark when it's gone past about 500 or 600 RPM. So you can see that little tiny mark there, just in the hole there. It's a texture there. That's about when the light comes on there, and you'll hear it spark about there. So that's basically your retard point. So you'd set your timing at maximum advance there, and then that's where when the light goes out is about where it'll advance to. So that's maximum retard there, and that's where it will advance to when it's running. So it'll actually spark there, as you can hear. It's retarded now. But when it starts spinning above about 500 RPM, it'll start sparking there, which is when the light comes on. Just there. That's where it sparks at fully advanced, and that's where it sparks when it's retarded, going slowly. Grab us the strobe, Tony, and I'll hook that up, and I'll see if we can't capture that. Just clip it on. Clip out. I'm working with one hand here. That positive on there. Pop that on the spark plug lead. Going the right way, yep. Just turn the lathe on, Tony. It's on 780. Forwards. That's it. And slow it down. Turn it up. Turn the lathe off. Yeah, that's it. We're not getting any strobe action here. Why not? Connected. I got that round the wrong way. That's fucking great. Blown up. Yeah, it should go now. Go for it. Actually, you go for it, mate. switch it off. Now watch it carefully. Stro's playing havoc with the phone. I don't know if you could pick that up. It looked like the strobe was making the phone camera go nuts. Just get rid of all that. Yeah, there you go. Anyway, so I don't know if I did a full screamer, but we'll do a full screamer now. 2,000 RPM. There's 2,000 RPM on the lathe there. Let's get that going. High speed. Make sure it's sort of safe. A bit dodgy. Anyway, so this is 2,000 RPM on the lathe times 9 on those holes. What's that? 18,000 RPM. Here we go. Well, there you go. That works. So, I mean, I don't know how permanent it's going to be or how reliable it's going to be, but it certainly works. What I plan to do now is I've seen some videos where people have pulled these apart or depotted them, and it looks like there's a lot of resin and sand makes up the bulk of the construction, whereas the circuit board and the cap are fairly low in the pot. Of course, I don't know for sure. They're not particularly expensive, so I'm not going to cry if I wreck one. But what my plan is I want to get on the milling machine. I just want to mill out a little pocket in this epoxy here. And then what I'd like to do is set all these components and this tiny little coil, which is necessary for it to run in, certainly in my case, and see if I can pop that all in there. Make a compact unit with just one plug on it, so it's nice and neat. Anyway, that'll be next, but first things first is this is working, and I'm very happy with that. Anyway, see ya.